So for this part of our geometry unit, we're going to determine if two figures are similar, and then we're going to use similarity to find missing angles and sides of similar figures. So it's important to know that similar figures are the same shape, like two triangles, but they do not have to be the same size, although they could be. And if two figures are the same shape and the same size, then they would be considered congruent. The symbol for similarity is this kind of like squiggly line. Corresponding parts are going to be two sides or angles of two similar figures that have the same relative position. So they're going to be sides or angles that are in the same spot. Sides of similar figures are proportional, which means they're going to form a proportion, and that's what we're going to use to help us find missing sides. And then corresponding angles of similar figures are congruent, or congruent, I don't know how you say it. This means they have the same measure. So what all of this means is that our sides are going to be proportional, but our angles are going to be the same size in similar figures. If all the corresponding sides of two figures are proportional, then the figures are similar. And if all corresponding angles in two figures are congruent, then figures are similar. So we can use angles or sides sometimes to help us determine if figures are going to be similar. So for example, in our first example, we have two rectangles, and we are going to determine if these figures are similar. And we're going to use their sides and see if their sides form a proportion. Now, of course, these two rectangles don't appear to be similar, as this one is more square-like and this one is much longer and thinner. But sometimes objects are not drawn to scale, so we're not going to use that as our go-to. We're going to set up a possible proportion. I'm going to put an equal sign there right now, but I really should almost have like a question mark there because I don't know if these sides are going to be proportional. I'm going to start with the side length 8, and so I'm going to put that into my possible proportion, and then I'm going to put that over 7. And so then in my other fraction, I'm just going to make sure that on the top I would have the side that corresponds to 8, and on the bottom I would have the side that corresponds to 7 if these two figures happen to be similar. And so since 8 is the longer of the two sides, I would go with the 10. And then since 2 is the shorter of the two sides, I would go with the 2. And to check if these are proportional, I can use their cross products. So I can cross multiply and see if their cross products are equivalent. If they're equivalent, then they're proportional. If not, they're not, and that will help me decide if they're similar. So one of my cross products is going to be 70. My other cross product is going to be 16. And 16 and 70 are not equal, which means they're not proportional, which means that no, these figures are not similar. So you try example 2, pause the video, set up a proportion, a possible proportion, to determine if these two triangles are similar. Press play when you're ready to check your answer. So in this example, I started with side length 12, and I put that over 5. Then I put 6, which would also be like the height of the triangle, so that corresponds to 12 if they're similar, over 2.5, which would be the base. And then I did the cross products. 6 times 5 is 30, 12 times 2.5 is also 30. So yes, these sides are proportional, which means that the figures are similar because the sides are proportional. On example 3, I'm being told that the two figures are similar using the symbol here. And because I know that similar figures have congruent angle measures, that's going to mean that angles P, Q, and R are going to be congruent to angles T, U, and V. And I can use this to help me match up my similar sides or angles. P, Q, R would match up with T, U, V in that order. So this would mean that angle P and angle T are going to be congruent. So angle T would be 20 degrees. Angle R and angle V would also be congruent, so this would mean that angle V would be 110 degrees. And I'm being asked to find angle U, which is here, which is going to be equivalent to angle Q. And so to do this, I could either find Q or U, and I would use the fact that in a triangle, the sum of my angles is 180 degrees. And so right now I have 110 and 20, which would make up 130 of my 180, which means that to find angle U, I could subtract 130 from 180 to get 50. And so this would mean that angle U and angle Q are both 50, but I'm being asked for the measure of angle U, so the measure of angle U equals 50 degrees. On example 4, I'm again being told that triangles JKL and MNP are similar, and so now I'm trying to find the side length of JL, and so that's this one right here. So I can see that that corresponds to side length MP. I also have side length JK, which corresponds to side length MN. So this time I know that my sides are proportional. I don't have to check because I was already told that they were similar. And so I can set up my proportion as 18 over x equals 24 over 32. There's a whole bunch of different ways you could set up this proportion. You could do 18 over 24 equals x over 32. You could have this whole thing upside down. Either way, we're going to use cross products now to solve like a proportion. So I'm going to cross multiply 24 by x to get 24x. Just like in an equation, my equal sign comes straight down. And then I would do my other cross product of 18 times 32, and I would get 576. And so now to solve this proportion, I have a one-step equation where x is being bothered by 24. So to undo that, I would divide by 24, and so x would equal 576 divided by 24 is 24. And so that means my unknown side would be 24 inches. On examples 5, 6, and 7, you're told that each of these sets of figures are similar. So that means you're going to use a proportion to solve for the missing side. For each problem, set up a proportion, show your work, solve for your missing side, pause your video, press play when you're ready to check your answers. So in this first one, I put 14 over 21 equals x over 15. I use my cross products. 21x equals 210. To solve this equation, I divide both sides by 21. And so my missing side UV would be 10 centimeters. Here I did x over 14 equals 40 over 35. Using cross products, I got the equation 35x equals 560. Divide both sides by 35 to get an unknown side of 16 meters. To help on this one, I can see that I'm trying to find side length KL. And so I took this image, and in my mind, I kind of rotated it to get it to match up. Now I can see that QR, if I do it this way, QR is what matches up with KJ, KL is what is going to match up with side length SR, and so that's my 48 feet, and so that's why I have my unknown here and my 48. And then in this quadrilateral, the only other side length that I have is 30, and so that's what I've got here, and that's going to match up with side length 36, which is over here. And so I can see my remaining side lengths that match up, but I didn't need to use those ones. So I'm matching up red with red and yellow with yellow to create my proportion x over 30 equals 48 over 36. Solve using cross products, and I get a final answer of 40 feet. So don't forget to complete the rest of the practice and to upload to Google Classroom just the 2 pages of the practice sheet.